Okay, good afternoon, good evening, parents and students. Today, I'd like to interpret or help you to interpret this cooling graphs. Okay, what do I mean by cooling graphs? Cooling graphs in examinations, the student will be shown the temperature on the vertical axis. And the horizontal axis, they will show the time, either in seconds or in minutes. So in a cooling graph, usually 3 lines will be shown. And you need to take note, they always start at the same temperature because you are comparing how the 3 setups experience the cooling. So from here, let's say, because here the temperature is not indicated, so maybe you just give a generic temperature, maybe like, because this is this setup is water, so I just put a generic temperature, 77 degrees Celsius. Okay, example. So at the beginning, the 3 setups have 77 degrees Celsius. That the thermometer is measuring the temperature of the water inside. Okay, so from here immediately, I will know that setup Z cools the fastest because the temperature, you can see the graphs have a very steep slope, right? So this indicates that setup Z cools the fastest. So now they ask you, after some time, Ben found the temperature of water in setup Y remain higher. Okay, setup Y, which is here, remain higher than X. So now you are supposed to explain why this remain higher. So you observe here. Okay, there's a characteristic here, the dry cotton wool. So what does dry cotton wool store or contain? They trap air, right? So air is a poor conductor of heat, right? So that's why this part, right, the water, the hot water, would lose heat slower compared to X and Z. Okay, you notice this water droplet here, right? It's not condensation because it's hot water. So this water droplet, they did not mention in the questions. So my best guess is perhaps the person doing it, Ben, spray water on this. So when you spray water on this will accelerate the cooling process. Okay, but it's not mentioned here because here they only ask you why the temperature in Y remain higher than the rest. Okay, so for this question, you just say that air is a poor conductor of heat. Okay, maybe before that you should say air is trapped in between. Air is trapped in between the dry cotton wool. Okay, air is a poor conductor of heat. Therefore, you see this part. Therefore, the cotton wool, right? The dry cotton wool reduce heat lost from the hot water to the surrounding air. Okay, this part. Air is trapped in between the cotton wool. Air is a poor conductor of heat. Therefore, the dry cotton wool reduce heat loss from the hot water to the surrounding air. Okay, so that answers the question. To answer even better, right? Because this is a 2-mark questions. You can also mention the Z. You can say the water droplets present on setup Z, right, increases heat loss. Okay, the water droplets in Z, right, increase heat loss of the hot water to the surrounding air. Okay. The water droplets in Z increase heat loss of the hot water to the surrounding air. So one is in Y is reduced heat loss. One is increased heat loss. Therefore, the Y has a higher temperature. So you take note of this. This is a cooling graph. So I snapshot this and send to you in your group there. You can download this before the class exit. Okay, sometimes you may be asked, what is the purpose of setup ZX? Okay, setup X is a control setup, right? Yeah. So you should say setup X is a control setup to show that the decrease in temperature or the rate of heat loss, right, is only due to the substances present on the surface of the container. Okay, so you must say it is a control setup to show that the difference in the temperature loss, right, is only due to the substance present on the surface of the container. Okay, so I send this to you already. Okay, do take note. Next week there's no class as scheduled, so you remind your parents. So you do the remaining homework. I will go through the answer with you. Okay, if I have time, right, I will upload the answer with my recording, right, and I'll inform your parents. So before we end, you need to turn on your video. I take attendance.